Welcome to our second video on log properties. So far we've been looking at taking logs and condensing them down into a single log, and now in this next part we're going to go the other way and try to take a single log, expand it out into multiple logs. So here's a few log properties that we looked at last time. I'll just reiterate. Log base b of x times y is log base b of x plus log base b of y. Log base b of x divided by y, so division inside the log, gives us subtraction, log base b of x minus log base b of y. And if I have an exponent, log base b of x to the r, I can take that exponent and bring it out front. So now this is r times the log base b of x. So last time we saw that these do come from the exponential properties. If you want to see a proof of that, it is quite involved, but we're just going to use the properties in this video to be able to expand the logs. Alright, so here's a log that I have, log base 7 of 5x over 4. And what I want to do is expand it out as a sum or difference of logs. And at the end, what I would like is to have all single logs with either single numbers or single variables inside and no exponents. So here's how we would start. I notice that this is a division, and so if we have a division, I know I can separate that into two different logs with a subtraction. So we'll go ahead and do that. Now I have the log base 7 of 5x minus the log base 7 of 4. So that numerator is the positive log, denominator is the negative log. So now that we have two different logs, log of 5x and log of 4, both with a base 7, we can still do one more step here. So the log of 5x is the log of 5 times x. So there's a multiplication right there between the 5 and the x. If I have multiplication in my log, I can still separate that even more. So we'll go ahead and separate that one step further. And now this is going to become a log of 5 plus a log of x minus log of 4, all with base 7. So the base continues through the whole thing, base 7 through all the steps. But now at the end we get log 5 plus log x minus log 4. Let's look at another one. So if I have this one, log of x over 4y squared z cubed. Okay, so here again I see a fraction, and so what I'm going to do is split that up with my subtraction property. And so this is going to be the log of x minus the log of 4y squared z cubed. After this, I can continue to work on this part over here where I have the 4y squared z cubed. So now I'm going to separate that. And a key to this is that you do have to put big brackets around any log that you're separating, especially if there's a negative in front. So we get the log of x and then minus this whole expanded form of that other log. So expanding this out, there's multiplication between the 4 and the y squared and between the y squared and the z cubed. So this now becomes log 4 plus log y squared plus log z cubed. All of that is being subtracted from the other log. So that's a key step right there. And now if you'll notice, I can distribute the negative and I get log x minus log 4 minus log y squared minus log z cubed. There is one thing I want to point out. So this x that's on top in the fraction, that is an x in a positive log. This 4 that's down there as a factor that's being multiplied, that's a 4 in the negative log. Y squared as well is also in a negative log and in the denominator. And the z cubed is also in a negative log and in the denominator. This is going to occur whenever we expand logs. So sometimes, if you're familiar with these properties, you can go ahead and go straight from something like this to something like this in one step. Every factor in the numerator of this big fraction is going to become the term in a positive log, and every factor in the denominator is going to become a term in the negative logs. So all of these get negative logs separated out. This term up here is positive log because it was in the numerator. Alright, and that follows just from these properties. So you can continue to do these if you want. Log x minus this guy, that log separates, but I do have to keep that negative out in front and distribute it through all of them. Alright, we'll see this again in another example where I can just take terms from the numerator, they get positive logs, terms in the denominator, or factors in the denominator, get negative logs. Alright, last step here, so we're not quite done. We still have exponents, and we want to get rid of those exponents. So that 2 and that 3, now I have exponents that can be written in front of the log. So now this is going to go the other way. So with the other problems that we had where we were trying to condense it down to a single log, the powers were the first thing that we took care of. Now they're going to be the last thing. So these powers are now going to go out front. And this is just going to become log x minus log 4 minus 2 log y minus 3 log z. So that 2 and 3 came out in front of the logs, and that's our final answer. One more problem here. Log base 2 of x times quantity x plus 1 squared divided by x squared plus 1 times x minus 3 all to the 5th power there. So this log that we're going to try to expand has a lot of different parts. And I'm going to go ahead and separate it out like this at first. So notice here I have the x in the numerator gets a positive log. This x plus 1 squared, that whole term, gets a positive log because it's also in the numerator. The x squared plus 1 gets a negative log because it's in the denominator. And the x minus 3 to the 5th also gets a negative log in the denominator. Like before, I can separate these out, do the division, but then make sure I have that negative that distributes to both of these terms that are down here. So log base 2 of x plus log base 2 of x plus 1 squared minus log base 2 of x squared plus 1 minus log base 2 of x minus 3 to the 5th. So I can go straight to that off of this single log here. Now what we want to do is look at the powers. So now that we've gotten that, we'll start looking at the powers. So which powers are ones that I can bring out front? So that's just going to be this 2 and this 5. So the 2 here, I have this whole x plus 1 being squared. So I can take that 2 and I'll bring it out front. I have this whole x minus 3 to the 5th power. So I'll take that guy and bring it out front. I can't mess with this x squared right here because I have a plus 1 right next to it. So unless it's an entire term being squared, I can't bring that exponent out front. So this one is just going to have to stay as is. I can bring the other 2 out, and so that 2 comes out front of the log base 2 of x plus 1. 5 comes out front of the log base 2 of x minus 3. So there's my final answer, log base 2 of x plus 2 log base 2 of x plus 1 minus log base 2 of x squared plus 1 minus 5 log base 2 of x minus 3. So the more terms, the more breath you have to take to say these things. The longer you have to write, more paper you'll use. But this is the general rule behind expanding logs. And in case you're curious, this is useful when you get to some calculus types of things. Most of what we're going to be doing is going the other way, trying to condense to a single log. That'll be most useful in solving equations, and that's what we'll look at next.